This is a video that's going to show you how to determine if a function has even or odd symmetry algebraically without producing a graph. But before we get into that, let's just review what even and odd symmetry does look like. So a function that has even symmetry is going to be reflected over the y-axis. So it's going to look like maybe a parabola who's only been moved up or down. Okay, it's going to have y-axis symmetry. Could look like this. Anything that's got, it's kind of lumpy, has y-axis symmetry. Odd symmetry is when we have 180-degree rotational symmetry around the origin. Our two most common functions that have odd symmetry are y equals x cubed, which looks like this, and of course its inverse, the cube root, and also the parent function for a rational function 1 over x. These have odd symmetry. Again, that's not the best graph. Functions that have neither even or odd symmetry, they might be symmetrical. They might have, for example, you might have a parabola that's been moved to the right. So we have here a line of symmetry. So we've got a line of symmetry, but it's not even or odd. Okay, so we want to formally define now, even symmetry is if I put in a negative value for x and I get back the same function value. So remember when we did, if we had a point x, y, we said that we used to say on a graph it had a buddy point negative x, y. For odd symmetry, if we put in negative x, what happens is we get back negative f of x. And that, when we did that graphically, when we had a point x, y, we said that it had a buddy point negative x, negative y. And just to formalize this again, basically what's going to happen is we're going to put negative x into our function, and we're looking to get the exact same function back. If we get the exact same function back, then it's even. If we put negative x in and we get the exact opposite of the function, the exact opposite, that means the function is odd. So let's take a look at these two examples, and that will help us have a better understanding of what's going on here. Algebraically determine if the function is even, odd, or neither. So number one, I have f of x equals x cubed minus 6x. So I'm going to go ahead and replace x with negative x. So there we go. All right, so now that I've done that, I'm going to go ahead and cube negative x, and that's like cubing negative 1 and cubing x. So negative 1 cubed is negative 1, and then x cubed is just x cubed. Negative 6 times negative x is going to be positive 6x. And since I have now shown that f of negative x, these are exactly the opposites. See how it's positive and then negative, negative, and then positive. I now know that this is an odd function. Another way to think about it, if I took f of x, which is x cubed minus 6x, and I negated it, negative f of x equals negative x cubed plus 6x. That's what I got. So that function is odd. Now I've got g of x equals x to the fourth minus 2x squared. So I'm going to do g of negative x. And I have to see all of these steps. Don't cheap out. Okay, so now when I raise negative 1 to the fourth power, I just get 1. And negative x squared is just going to be x squared. And I get the exact same thing for g of negative x, which means that this function is even because it's exactly the same. All right, so at this point, let's do one more, and then I would like you to pause the video and try a few. So number 3, we've got x squared plus 2x plus 1. So we're going to do h of negative x equals, oh, that's why it keeps moving, because I keep bumping it with the pen. Okay, so now when I square negative x, I get x squared minus 2x plus 1. So here, the first term is the same, the second term is opposite, the third term is the same. This one is neither even nor odd. Okay, so why don't you go ahead and try the next 4 on this page, pause the video, and then I'll work through them quickly and we'll see what we all get. All right, so for number 4, you should have paused the video. I got x squared plus 6, which is exactly the same. So that means it's even. Now number 5, I have g of negative x equals 7 over negative x minus, which gives me negative 7 over x plus x, and that's exactly the opposite of this. So this is going to be an odd function. So now I'm going to do h of negative x equals negative x to the 5th plus 1. That's going to be negative x to the 5th plus 1. Okay, so this one, the first term is opposite, the second term is the same. This is neither. Number 7, I've got f of negative x equals 8. And that one is even, comes up exactly the same. All right, so there are 2 more. So this one's a little different because I've got an absolute value. If I have negative x, the absolute value of negative x is just going to be the absolute value of x, because it doesn't really matter that this is negative, it's still going to come up the same. So that one is even. And now g of negative x. And again, please do not cheap out. Please, it's not a lot of work here. If you have even or odd with no supporting algebra, I'm not taking it. Sorry. Not sorry. All right, so let's see. Negative 1 to the 6th power is just going to be 1, so it's just going to be 1/4 x to the 6th. That's just going to come up x squared. Oh, and this one's exactly the same, so it is even. All right, your homework tonight is page 13. It's not too long. Try it out. Here it is. Answers will be on Drive. Oh, and at the bottom.